Hello, calculus students. How you doing? How you doing? Oh, what is that? What is that? There's a weasel in my sweater. All right, so we're going to graph y equals x minus 1 times x minus 2 times x minus 3. Well, what's going to happen with that thing? Well, here's the graph, graphed it by hand, because you can tell. It's got an intercept at 1, an intercept at 2, and an intercept at 3, because 3 makes this thing 0 times 1 times 2, which is 0. Y coordinate 0. Y coordinate 0, y coordinate 0, but it's got to be a polynomial shape. If you don't believe me, I graphed it on my calculator. Let's see if I can get a picture. Come on. Come on, show it to me. It's not that bright. No, it's so useful. There we go. There it is. Okay. Now, what do we do? Well, here's what we're going to use calculus for. I'd like to find the location of those two bumps. And what's interesting is even though the curve is nice, it goes through 1, 2, and 3. This bump does not occur at 1.5. This bump does not occur at 2.5. They don't happen right midway through. And let's do the math to see how it goes. So, here's what we do. The derivative of x minus 1 is 1 times x minus 2, x minus 3, plus the derivative of x minus 2 is 1 times x minus 1 times x minus 3. The derivative of x minus 3 is 1 times x minus 1 times x minus 2. Oh my goodness, we have to multiply out 3 pairs of binomials. So I've got the multiplications underneath each. I was careful. I just did a good job. All right, and then I added like terms. And this is my quadratic, which is, why is that quadratic good there? Well, because this is my bump locator. That's my bump locating thing, and because it's a quadratic, it says there's going to be 2, which I already knew. I knew there's going to be 2 bumps. But now watch this. A very cool thing happens. Because I'm just doing quadratic formula, putting in the numbers here. And this is positive 12 from negative 12. Plus or minus the square root of 12 squared minus 4 times 3 times 11. This whole thing in here comes out to be a 12. So I have plus or minus the square root of 12 over 6. And then 12 over 6, because everybody's over 6. 12 divided by 6 is 2. Now check out how cool that is. It's plus or minus, 2 plus or minus, square root of 3 over 3. Now why is that cool? Because it's 2 plus a little bit more, and 2 minus a little bit more. Now look where those bumps are supposed to be. It's 2 plus a little bit more, that's where a bump is, and 2 minus a little bit. And that's where the other bump is, which is where it says it's going to be. Now we're going to do the actual calculations, and you can watch the weasel while I pause. Oh, where'd the weasel go? Where'd the weasel go? All right. Now, I took the numbers that we got from the quadratic formula, and I put them in for x. I'm going to do the 2 plus square root of, I'm going to do the 2 plus square root of 3 over 3. That's this, trying to find that point. So I'm expecting to get a negative y coordinate. So let's see what happens. 2 plus square root of 3 over 3 minus 1. 2 plus square root of 3 minus 2. 2 plus square root of 3 over 3 minus 3. Well, when I do the 2 minus 1 is 1. The 2 minus 3 is negative 1. And I spotted difference of squares. All I have to do is think of this as square root of 3 over 3 plus 1 times square root of 3 over 3 minus 1. You just square this, write a minus sign, and square that. Well, 1 squared is 1. Square root of 3 over 3 squared is 3 over 9, otherwise known as 1/3. So we have 3 over 9 minus 1 times square root of 3 over 3. That's all this stuff, which comes out to be 1 square root of 3 over 9 minus 1 square root of 3 over 3, which is 3 square roots of 3 over 9. So 1 minus 3 is negative 2. Negative 2 square root of 3 over 3. This point right here, that point right there, is not as clean as you would think it would be. That's the point 2 plus the square root of 3 over 3, comma, negative 2 square root of 3 over 3. That's that point. So notice it's not exactly halfway between 2 and 3 on the x-axis. The y-coordinate's also not, famously nice either. And that's how it happens a lot when you have a polynomial that's not perfectly balanced across the y-axis. You don't get that symmetric location of bumps. So this is a pretty typical thing. Try and keep this one in mind. Let's recall what we did. We knew what the graph looked like, but we wanted to find the exact locations of those bumps. I only did this bump. The other one's similar. You got to use the quadratic formula and plug it in. Anyway, so here's what it looks like when you plug in a nasty quadratic formula. You think it's going to be awful. It wasn't so bad. It wasn't so bad. It looks like a lot of work, but the math wasn't that tough. I mean, 3 plus or 3 minus 1, 2 minus 2, you know, these weren't too tough. All right, you guys, that's where we are as of September 21st.